Hey guys, welcome to my YouTube channel. So previously in this channel, like you have seen a lot of lead code tutorials and some back-end engineering stuff. So currently, since I'm working as a AI engineer, I want to do more AI focused content since I'm more experienced in that. And as most of you were asking in some of the previous videos, yeah, I have moved to Bangalore from California, and I'm working in a company as a AI engineer. So my primary job is to build and deploy AI agents. So today we will be looking into one such task, that is like connecting MCP servers into AI agents. So basically, like I'm sure you have seen like a lot of tutorials which shows you how to build AI agents using LangGraph or any other frameworks, and how do you connect MCP servers into it. And these tutorials work well. Like I'm sure there are plenty of tutorials available and they all work well. But taking it into production is a different issue altogether. So I have personally seen it. You can build AI agents connected to MCP servers and memory, whatnot easily. But when you actually think of taking it to production, there are like couple of issues that comes up. So that's why I'm going to touch upon one specific problem today, that is connecting MCP servers to your AI agent. And for this, I'll be referring this document by Anthropic, Code Execution with MCP Building More Efficient Agents. And when this document came out, I know it became viral in Twitter because this was so obvious. Like many people were facing these issues, and this document clearly highlighted all that. So basically, I'll explain you what happens, right? So basically, when you connect your MCP server into your AI agent, MCP server consists of many tools. So when you load your MCP server into AI agents, all these tools will be loaded into our AI agent. So what do I mean by that? A tool is described by these things. Like a tool will have like a description, it will have like parameters that it takes, and it will also have like a return value. So this is fine when you have like two to, like, let's say even if you have like 6 7 tools, this is fine loading this into your context window. Let's say your MCP server has like 30 tools, 35 tools, or even more than that. Then every time you connect your MCP server with your agent, you will be loading all these tools, which consist of description, parameters, everything into your AI agent. So let's say an LLM has a context window, right? So if you keep loading these many tool descriptions every time you connect, this will flood your context window, and your context window will be basically not enough to accommodate all these tool definitions and everything. So this is one of the primary problems. So most of us, we just think that yeah, we have an AI agent, so we want to make use of couple of tools. So I can just connect to any of the MCP servers and it should work fine. But that won't work in production because you need to see how much context window your LLM has. Let's say your AI agent is using like something like Claude, and let's say it has like a context window of 1 million. 1 million is a relatively huge context window. Let's say you have like 250K as your context window. So in that case, you need to make sure whatever context you are providing to your LLM, that could be your tools or your previous memory, whatever it may be, it should be within that 250K tokens. Otherwise, you will get an error during when you have deployed it. So how do we manage this? So I hope it's clear to you that it's pretty obvious that you shouldn't be like sending all the tool definitions into MCP from the MCP server into your agent context window, because that will overflood it. This is the primary thing that you shouldn't be doing. And again, one small caveat here is it's fine if your MCP server has a very small list of tools. I think a rule of thumb is if it has around 6 7 tools, it's fine. But if you have like more than 20, like a lot of tools, then definitely you need to avoid sending all these tool definition into the context of the LLM. So this is the primary problem. And one more thing is intermediate tool results consume additional tokens. So let's say like you make a tool call, okay? You make a tool call to some database or an Excel that has to retrieve like 10,000 records. Now you retrieve those records, 10,000 records, and you load it into your LLM context window for processing. That's again like very bad because that will exhaust your LLM context window. So that's what they're talking here. Intermediate tool result consume additional tokens. So whenever your tool returns some result, and if you are like flood taking that result and putting it into your LLM context window, that will flood your LLM context window. And it's fine again, like if you're making small tool calls which gives you results which are less than, let's say like 100 tokens, or let's which is consumes less number of tokens, that is still fine. But the example I gave you, right, like if you are retrieving like 10,000 records and putting that back into your LLM context window, then it definitely won't work. So this is why I'm highlighting all the tutorials which we follow on YouTube. They deal with small examples. They take tools that give you like small results. But when we are dealing with production, that's not the case. That's why we need to be careful in managing the context window. So I just explained you all the problem that comes up when we are loading MCP tools into agent. So what is the solution here, right? So one of the solution that Claude has come up with is code execution, which is like having a code execution sandbox. So what do we mean by this? Like it seems like a lot of jargons, right? So basically, if you see here, we have a server, and Google Drive, Salesforce, all these are like basically whatever tools we had, they are converted into like some file. It can be Python file or TypeScript file in this case. So basically what they are telling is have like a separate code execution environment instead of having like a MCP server and tool calls. In this code execution environment, have all your tool calls as a Python file or a TypeScript file, and then just do like a ls of your file directory. In this case it's server. Just do ls of your file directory, and just based, let's say your task is to list some files from Google Drive and load it into the Salesforce. I'm just taking that example because we have those two tools here. So in that case it will just load based on, because we told use load some files from Google Drive and load it into Salesforce. It will just load these two Python files, and it will just use them instead of loading the entire tool list that is in the server. It will just load only the required files as per our prompt, sorry, as per our user query, and it will just use them, and this will consume way less token rather than loading all these set of tools into our LLM context window. So this is one of the approaches that they have suggested, that have like a code execution environment, and then you can just load the relevant files required and then just execute it. And the execution also happens in this code sandbox, and only the final result will be sent into the LLM context window. So that intermediate tool result problem that we were talking about, right, previously, intermediate tool result token consumption, that problem also will be solved when you do this. And yeah, that's pretty much about how to solve this problem. And there are also a couple of other optimizations that they have talked about. Let's see, like there is one specific thing I wanted to address. Let me check where they have that. So basically one other thing was they were having like a search tool. Yeah, so alternatively a search tool can be added to the server. So we have like all the files in the file system, and we can also have like a search tool that finds the relevant definition. So it basically goes through, it will basically decide which files to call, so that you can only like retrieve those specific files and execute it and search. And let me just read it out for you so that you can clearly understand it. Alternatively, search tool can be added to the server to find relevant definitions. For example, when working with hypothetical Salesforce server used above, the agent searches for Salesforce and loads only those tools that it needs for the current task. So let's say we have like a server, and you want to only load specific Salesforce specific tools. Then you specify a Salesforce as a parameter for search tool, and it only loads those specific tools, which includes Salesforce. That allows the agent to select the level of detail required. Like you can only load those names, or based you can filter based on name, definition, or description. So basically, instead of here, we would, in this case, we would basically do an ls, and based on the user query, we would load the specific files required. Or you can also have like a search tool that would retrieve specific tools based on the parameter. Parameter can be name, description, or the full definition with schemas. So whatever you give, based on that, you can retrieve that specific tool. So yeah, that's pretty much it. These are the two approaches. One is, let me just summarize it for you. One is having like a file system, like basically instead of having a MCP server, have a file system which consists of all your tools as a Python files or a TypeScript file, and just do an ls of the file directory and load that specific files which are required based on your user query. That's one approach. The other approach is have like a search tool, which basically, like, out of all these MCP tools, it specifically loads relevant tools based on the filter parameter that you have provided, and we will only load those tools into the LLM context. So following these two methods, you can reduce the context window used by your LLM, and your AI agent won't break in the production. So that's it for today, guys. Like we just discussed how to optimally use MCP server with our agent in production, basically. So thank you for watching my YouTube video, and stay connected for more such content.